"I can't write the code," was the constraint, and it turned into a million-line code base anyway. Ryan Lopopolo at OpenAI says his team built an internal tool with Codex, moved past even human code review, and discovered the real bottleneck was human attention. Welcome to X-Pulse Digest. Ryan unpacked the playbook with latent space, and it changes how you think about developer productivity when the developer is infinitely parallel. The origin story is simple. Ryan's team sits in OpenAI Frontier, doing frontier product exploration for the enterprise platform. Ryan picked a constraint that sounds like a stunt until you feel the logic of it. He decided he personally would write zero code. Not less code. Zero. Because if you're trying to sell agents that can do what enterprise employees do, you don't get to hand-wave the parts where the human quietly saves the day. That constraint forces a different kind of engineering. You stop asking, "Can the model code?" and start asking, "What did we fail to give it so it can reliably code here, in this repo, under our standards?" That's harness engineering in his framing. And it's not instant magic. Early on, with the first Codex CLI versions and the smaller model, asking for a feature could fail to assemble the pieces. The move was to double-click the task and build smaller blocks the agent could recombine. The first month and a half was, by his estimate, 10 times slower than doing it himself. They paid that tax so the system could become faster later. You're not grinding tickets. You're building the assembly station. One practical surprise is how model releases force changes in the code base itself. They lived through multiple generations, and Ryan describes it like learning each model's working style. A detail that sounds small ends up shaping architecture. At one point, the Codex harness didn't have background shells, so long blocking scripts were fine. Then background shells arrive, and suddenly the agent is less willing to wait around. So the team retooled the build system to complete in under a minute. Not as a nice-to-have, as a hard invariant. If the build goes long, that's treated as a signal to stop, decompose the build graph, and get time back under the limit so the agent can keep operating. They churned through tooling quickly. Makefile to Bazel to Turbo to NX, because the only opinion that mattered was speed. The under-a-minute rule is really a rule about flow. The agent can't afford your 12-minute build, and neither can you once you've seen the alternative. If you want to understand the method, stop picturing a clever prompt and start picturing a repo that teaches. A big theme is getting what good looks like out of engineers' heads and into artifacts that land in the agent's context. Docs, tests, lints, review agents, error messages that tell you how to do the right thing. Ryan describes it as encoding non-functional requirements into spaces that prompt inject the agent. When the agent makes a mistake, it's not just a bug, it's misalignment with some requirement you haven't written down yet. They also invert the usual setup. Instead of building an environment and then dropping an agent into it, they start from Codex as the entry point and give it skills and scripts so it can boot whatever stack it chooses. And there's this move where they use operations incidents to improve the repo's written norms. If a missing timeout triggers a page, you can add Codex in Slack and say, "Fix the timeout," and update the reliability documentation so all network calls require timeouts. Now the point fix becomes durable process knowledge. Models crave text, he says. Their job became figuring out how to funnel text from one agent to another, and from the real world back into the repo. The most uncomfortable part for a lot of teams is where the human sits in the loop. In their case, human review moved to post-merge. The logic is blunt. The model is trivially parallelizable. The scarce resource is synchronous human attention. So they started treating the SDLC like a system to be engineered. Where is the agent making mistakes? Where is the human spending time? How do we stop spending that time and build confidence in the automation? They built code review agents that comment on PRs. But then they ran into a dynamic between two agents. The authoring agent was too willing to be bullied by the reviewer agent, and you could get non-converging loops. So they changed prompts on both sides. Reviewer agents were instructed to bias toward merging and not surface anything higher than a P2 priority. The authoring agent was given permission to defer or push back, because not every review comment is meant to double the scope. This matters if you try to copy it. Agents follow instructions. If you don't explicitly encode FYI, backlog this, they will try to satisfy every request immediately, and you get thrash. They also delegated the PR lifecycle to a skill. Push the PR, wait for reviewers, wait for CI, fix flakes, merge upstream if it conflicts, put it in the merge queue, keep going until it lands in main. There's a claim in here that got attention. Software dependencies start to go away because you can internalize them. Ryan agrees with a constraint. The complexity they can internalize right now is low-medium based on model capability. His concrete definition of medium is a couple thousand lines, something they could in-house in an afternoon. The twist is that you often don't need most of the generic dependency anyway. Once you internalize an abstraction, you can strip it down to only what your product needs. There's also a security and velocity angle. With Codex security on the repo, the agent can review and change internalized dependencies without the friction of pushing patches upstream, waiting for releases, and juggling compatibility. But Ryan also acknowledges the counterpressure. If you internalize a dependency, you're back to zero in terms of confidence, and you have to rebuild trust. His most telling example is a debugging story. They had performance issues, got exported traces, and an on-call engineer used Codex to build a nice local tool to visualize the trace. It took an afternoon. Then, the punchline, none of it was necessary. You could just spin up Codex, give it the tarball, ask what's wrong, and get the response immediately. Optimizing for human legibility was the wrong move because it kept a human in the loop. That's the mental rewrite. You're not building tools so humans can stare at traces. You're building systems so the agent can fix the thing. Once you accept that agents can generate code, tests, CI config, docs, dashboards, and even review comments, you hit a new wall. It's not capability, it's coordination. Ryan gives a number that makes the pain concrete. By late December, they were at about 3.5 PRs per engineer per day. Then, a model release lands, and they jump to 5 to 10 PRs per day per engineer. That output is taxing, because humans end up context switching between terminal panes to keep agents moving. So they built Symphony, an orchestration system intended to remove the need for a human to sit in front of their terminal. There's a dream end state where you open it twice a day and just say yes or no. A key design choice is disposability. When a PR is escalated for review, the review should be cheap. It's either mergeable or it's not. If it's not, Symphony moves it to rework, trashes the work tree and PR, and starts again from scratch. That sounds reckless until you hear the governing idea. If it was trash, you pause and ask why it was trash. Then you fix the harness or the context so it doesn't happen again. Symphony is also where the repo starts looking like it's built for a 10,000 engineer organization, not a 7-person team. Ryan says they ended up with something like 500 NPM packages and rigid boundaries, because each human effectively has many agents. Without structure, you get people trampling each other. There's an honest downside, too. When you're this removed from the loop, you can lose track of what the codebase even looks like. It's a funny reversal. We built tools to avoid talking, and now we talk to understand the tools we built to avoid talking. All of this points at why OpenAI Frontier exists. The pitch Ryan gives is that Frontier is the platform to do AI transformation of enterprises, making it easy to deploy highly observable, safe, controllable, identifiable agents into the workplace. That means governance and security tooling, connectors into the tools employees already use, and customization hooks that let an enterprise encode its own safety specs. He mentions safeguard models interfacing with a safety spec, and the reality that enterprises care about bespoke things like internal code names and exfiltration risks. There's also an iceberg product shape. The end user is the employee using agents in the surfaces they already live in. The dashboard and control plane is for IT, GRC, AI innovation offices, and security teams who need to get to yes in a way that matches regulatory requirements. And if you want a cleaner mental model for why harness engineering matters here, Ryan's view is that you should avoid building a separate scaffold that restricts Codex in unnatural ways. He wants guardrails that are native to the output the agent already produces, which is code. Tests, lints, error messages. That's on policy for good engineering, and it won't fight the model as it advances. In other words, the enterprise version isn't a fancy prompt library. It's a system for making organizations trust what the agent did without shoulder surfing every step. The sharpest reframe Ryan offers is that the job isn't to watch agents so they don't mess up. The job is to notice how they mess up, then encode the fix into the repo so nobody has to notice again. That's why the 1-minute build matters. That's why timeouts become documentation. That's why review agents need permission to be practical. It's also why code is disposable isn't nihilism. It's a strategy for restarting cleanly and improving the system. If you want the full texture, including how Symphony loops a spec into an implementation and back again, and how this ties into OpenAI's enterprise platform, listen to Ryan Lopopolo on Latent Space. If the only scarce resource is human attention, what part of your workflow is still designed to waste it?